What if I told you there's a moon where the sun rises in the west, or a place where a single day lasts longer than its entire month? The planets get all the attention, but the real weirdness? That happens on the moons. Welcome to Time Across the Solar System. I'm Tess, your AI host, and today we're venturing into the strangest corners of our cosmic neighborhood, the moons where time itself seems to go sideways. Phobos, the moon that rises backwards. Let's start with Mars. You probably know Mars has two moons, Phobos and Deimos. But Phobos does something that would break your brain if you saw it. Phobos orbits Mars so fast, just 7 hours and 39 minutes, that it actually overtakes the planet's rotation. Mars spins once every 24 hours and 37 minutes, but Phobos completes an entire orbit in less than a third of that time. Here's what that means in practice. If you stood on the Martian surface and watched the sky, you'd see Phobos rise in the west and set in the east. The exact opposite of every other celestial body you've ever seen. And it doesn't stop there. Because Phobos moves so quickly, it rises, crosses the entire sky, sets, then does it all over again twice in a single Martian day. Imagine explaining that to ancient astronomers. A moon that defies the rules, a moon that moves backward across the heavens and visits you twice before dinner. But Phobos has a problem. It's spiraling inward. Every century, it gets about 1.8 meters closer to Mars. In roughly 50 million years, Phobos will either crash into Mars or more likely be torn apart by tidal forces into a spectacular ring system. Enjoy it while it lasts. Phobos is living on borrowed time. Titan, a year of endless seasons. Now let's travel to Saturn's largest moon, Titan. This is the only moon in our solar system with a thick atmosphere. It has lakes, rivers, and rain. Not water, mind you, liquid methane. But still, weather. Titan is tidally locked to Saturn. That means one side always faces the planet, just like our moon always shows the same face to Earth. A single rotation takes about 16 Earth days. But here's where it gets strange. Titan's day and its orbital period are identical. 15 days, 22 hours, and 41 minutes. On Titan, 1 day equals 1 month. The sun rises, crawls across the sky for nearly 8 Earth days, then sets for another 8. Now think about seasons. Saturn takes 29 Earth years to orbit the sun. Titan goes along for the ride. That means a single season on Titan lasts about 7 Earth years. If you were born on Titan during spring, you wouldn't see summer until you turned 7. You wouldn't experience a full year, all 4 seasons, until you were nearly 30. Imagine planting a garden around that. We'll harvest sometime in the next decade. The Huygens probe landed on Titan in 2005. It sent back images of a frozen landscape with rounded pebbles, smoothed by flowing liquid, just like river rocks on Earth. Except those rivers flow with methane at minus 179 degrees Celsius. Same processes, alien timescales. Io, the moon of eternal noon. Jupiter's moon Io is famous for being the most volcanically active body in the solar system. Over 400 active volcanoes constantly reshape its surface. But let's talk about something else. Its relationship with time and the sky. Io is tidally locked to Jupiter. 1 Io day, 1 complete rotation, takes 1.77 Earth days, or about 42.5 hours. But here's the thing about tidally locked moons. If you stood on the side facing the planet, Jupiter wouldn't move. It would hang in the same spot in your sky. Forever? From Io's surface, Jupiter appears about 40 times larger than our moon appears from Earth. A colossal striped giant, frozen in place, dominating the heavens. On one hemisphere of Io, it's always Jupiter rise. The gas giant hangs eternally on the horizon. On the opposite hemisphere, you'd never see Jupiter at all. And in between, Jupiter hovers directly overhead. A permanent noon of planetary presence. The sun still rises and sets on Io. Day and night still cycle. But Jupiter? Jupiter is geography. Your experience of the sky depends entirely on where you stand. And here's something haunting. Io orbits so close to Jupiter that the giant planet's gravity constantly stretches and squeezes the moon. That's what powers all those volcanoes. Io is being kneaded like dough forever by the sheer gravitational weight of its parent planet. Time on Io isn't just measured in days, it's measured in eruptions. Europa, the moon with a hidden ocean. Now let's visit the moon that might just change everything we think about life in the universe. Europa, Jupiter's ice-covered enigma. Europa is slightly smaller than our moon, but don't let its size fool you. Beneath that cracked, frozen surface lies a global ocean of liquid water, more water than all of Earth's oceans combined. Europa is also tidally locked to Jupiter, completing one rotation every 3.55 Earth days. That's also how long it takes to orbit the giant planet. 1 day equals 1 month. But here's what makes Europa special. That same tidal kneading that powers Io's volcanoes? It heats Europa from within. Jupiter's immense gravity flexes the moon's interior, generating enough heat to keep an ocean liquid beneath kilometers of ice. Think about that. In the freezing void of space, 5 times farther from the sun than Earth, there's a world with warm, salty water, possibly flowing around hydrothermal vents on the ocean floor. On Earth, life thrives around hydrothermal vents in total darkness, far from sunlight. The same conditions might exist on Europa right now. The surface tells a story too. Those reddish-brown streaks you see in photographs? Scientists believe they're salts and organic compounds pushed up from the ocean below. Europa is literally painting its secrets on its skin. NASA's Europa Clipper mission launched in 2024 and will arrive in 2030. It will fly past Europa nearly 50 times, scanning for plumes of water vapor, measuring ice thickness, and searching for signs of habitability. If we ever find life beyond Earth, Europa might be where it happens, not on a planet, on a moon. Our moon, the familiar stranger. We've traveled to Mars, Saturn, and Jupiter. But what about our own moon? Surely there's nothing strange about something so familiar? Think again. Our moon is also tidally locked. 1 lunar day, sunrise to sunrise, takes 29.5 Earth days. That's 2 weeks of continuous daylight, followed by 2 weeks of continuous darkness. During the lunar day, surface temperatures reach 127 degrees Celsius, hotter than boiling water. During the lunar night, they plummet to -173 degrees Celsius, colder than any natural temperature ever recorded on Earth. A single afternoon on the moon lasts longer than a week on Earth. You could watch the sun creep across the sky so slowly that you'd barely notice it moving. And here's a beautiful detail. From the moon's near side, Earth never sets. It hangs in the sky permanently, a blue marble slowly rotating, showing you continents and oceans in real time. Astronauts on the Apollo missions reported that watching Earth was one of the most profound experiences of their lives. A silent, spinning world, their home, suspended in the void, going through phases just like we see the moon go through phases. From the moon, you can watch weather systems form over the Pacific. You can see the lights of cities blink on as continents rotate into darkness. That's our moon, close enough to see with your eyes, strange enough to remake how you think about time. Try it yourself. So here's what I want you to do. First, visit tatssp.com/moons. That's tatssp.com/moons. Explore our 5 featured moons: Phobos, Titan, Io, Europa, and our own moon. There are another 20 to read and learn about. Use the age calculator to discover how old you'd be if you'd lived your whole life on Titan. Spoiler, probably not even 1 Titan year old. Read the vignettes we've written about what daily life might look like in these extraordinary places. And if you want to compare, head to our planet pages and see how a day on Io stacks up against a day on Mercury. Calculate how many Phobos orbits happen before you finish breakfast. The moons are where the solar system gets personal. They're where orbital mechanics become something you can feel, something you can imagine living through. Oh, and teachers? We've got lesson plans ready. The moon section is perfect for discussions about tidal locking, orbital resonance, and why Earth's moon is so crucial to life as we know it. Time across the solar system is produced with passion for science, education, and wonder. Every script is human-written, every fact is NASA-verified, and everything we create is free, forever. If you believe in making science accessible to everyone, consider supporting us at tatssp.com/sponsor. Every donation helps us create more content like this. Until next time, keep looking up, keep questioning, and never stop wondering what time really means.